Welcome back. In this lecture, we are going to see how to use query execution plan in SQL Server. I took a sample example and I'm going to walk through this. I will also show you the demo how to generate a query execution plan like this and how to use your query execution plan to fine tune the queries. So how do you read this query execution plan? You are reading from this side, which is a control flow. Whenever issued a query, it has been flowing like this, and there is a plan given by the SQL Server and executing the query like this. And your data flow starts from this side, and you make sure that you read this data side. If you want to track the data, first it goes into the cluster index scan and goes into the index seek and the nested loops, and then it gets the data, and then it keeps passing like this. So you have to read like this if you want to read from the data side. If you want to read the control flow, you have to read from this side. Now, how do you find this query using this? You see that some of them 68.6% is taken by this, especially index seek. And that's where majority of the time the query is spent. If you want to change the indexes and test it out, you can see that any performance improvement that comes over. I'm switching back to the SQL Server Management Studio. Here, I'm going to select a table, select star from table. Before you're going to write a select query, you go back to the top. Here you see that there is an option called include actual execution plan, or you can say control plus M. You can do anything. So I'm going to click on this. You enable the query execution plan for this query. Let me execute this query. You see that you're getting an execution plan after this. You see this is the execution plan for this query. Issued a select statement, it did a stable scan and retrieved those results. It took 0.001 seconds. If you hover on the table scan, you can able to see the physical operation, logical operation, actual execution mode. The major items you want to look at is IO cost, CPU cost, what is my IO and CPU cost for this query, and what is the estimated number of rows that it is going to scan it. So there are 6 rows in this table, it is going to run all the 6 rows. In this example, I'm going to create 3 tables, one with table with no index, one with table with a cluster index, one with table with non-cluster index. So I'm going to create a no index table, a cluster index table, and a non-cluster index table. I'm going to insert 1 lakh rows in all the 3 tables. Now, the cluster index is created on ID column and a non-cluster index is created on ID column. Now we want to see which select query is performing better on these 3 tables. And how do we use the execution plan to measure the performance? Let's take a look at it. So I'm going to issue a select statement. So where ID between 1 and 1 lakh, it is same for all the 3 tables. Now what will be the output you think? Which query will perform better? What do you think? If you're thinking cluster index, you're right. Let me execute this together. So I've got the execution plan available, and then I just go up and see it. You see this execution plan, it is a batch. So there are 3 select statements. It is executed as a batch. It sees the output is calculated based on the relativity of the batch. For example, the first query cost is 49% inside this batch, and the second query cost is 5%, and the third query cost, which is using non-cluster index, taking 46%. So your cluster index, comparatively to your no index and non-cluster index, is performing very well. So 5% only took time to retrieve these values. So yes, we understand that for no index column, it goes for 49%. So that is fine. But how come non-cluster index taking so long to retrieve the result cells? If you see this query execution plan, it is doing a table scan rather than a non-cluster index. So the table is fully scanned and it is not applying the non-cluster index. Why is it so? Let's go and force it, the SQL server, to use this non-cluster index rather than a table scan. Sometimes we think that by forcing the index, we get better results. But SQL Server is smart enough to identify when you apply a non-cluster index, it is taking performance wise very low compared to the table scan. So that could be the reason it ignored the non-cluster index. So let's test it out. So I'm going to just move it down, that query. Now what I've done is for the non-clustered index, it is not using the index that has been created. I'm forcing this table to use the index I have created. So with index, so I'm forcing the table to use with index. We'll use this index. And let's see what happens to the performance now. I'm going to execute three select statements together. I go to the execution plan. I just pull it up to read it. I got an error message. Let's see. Incorrect syntax nearby. And that's why your third query doesn't execute. So let me see. Select start from this with index. So I have to put a close bracket. That is the reason it didn't execute. Now let me execute these three select statements together. I'm executing it. I'm seeing the execution plan. So if you see this, the first one, now it became 13% in the batch. The second query cost 1%. If you force to use the non-clustered index, the query is performing very, very badly. So that's why the previous query, when we used it, it uses a table scan rather than using the non-clustered index. What we understood is not all the indexes are good for the table. So we can use the query execution plan to identify which index is good for the table. To conclude, it's very important to understand to use a query execution plan to understand which index is good for your tables and then identify the right indexes and apply it